Okay, welcome to my channel. We will be doing question number 5, part 1 first. So this is very simple question. It's chapter 12 I'm talking about. Okay, so before I proceed, what is a sector? Sector is a part of a circle. Okay, so if this is the center and this portion with some angle theta, this is called a sector. So the area of a sector is given by 1/2 theta r square. And similarly, this arc length, right? This arc length S is r theta. Okay, now what is given in this part? The area of a sector is given as 36 centimeters square. So area which is half theta r square, this is given as 36. Okay, so from here I can find the relationship between r and theta. Okay, so you can see that theta is equal to 36 times 272 over r squared. Okay, so this is theta. Now part 1 says show that the perimeter is this much. Okay, so how can I find the perimeter of a sector? You can say it has two radial distances r and r. So it is going to be 2r plus this arc, which is s theta, r theta. So I can say this is r theta. Now, if I replace theta by this expression, I will get 2r plus r into theta is 72 over r squared. So this will become 2r plus r cancel with 1r, it is 72 by r. So this is the perimeter in terms of radius if we know the area. Okay, now part 2, it says, hence given that R can vary, find the stationary value of P and determine its nature. Okay, so we need to find the stationary value of P. So what we will do, I will differentiate this function P with respect to R, dP by dr, and it is going to be 2. And here, okay, you see, I can write it as 2r plus 72 into r power minus 1. So when I differentiate this thing, it is plus 72 is constant, and then power, and then r power minus 1 is minus 2. Okay, so this is 2 and minus 72 over r square. Okay, so this is our okay. I need to equate it to 0 to find the stationary point. Okay, so when I solve this thing, it is going to be 72 over r square equals 2. So r square is equal to 72 by 2, which is 36, and taking the square root, r is equal to 6 centimeter. Okay, and again, I find this machine. Okay, so you can see that if R is 6 centimeter, then we have uh, the minimum value of the perimeter. Okay, why am I saying so? Because if you see the expression for perimeter, this is perimeter, right? Okay, you can see if I try to sketch perimeter versus R, you can see that this part is increasing linearly, right? But this part this is basically the thing, yeah. Okay, the second part is increasing linearly when r is not linearly but inversely when r is small. So at small r, it is this expression is going to be very large, and at large r is also very large. So there's some value of r for which the perimeter is minimum, and that is the stationary point. And we just found that if r is equal to 6, then the perimeter is going to be the minimum. Okay, so this is it. I hope you enjoyed this thing, this presentation. If you have any question, you can always ask in the comment section. See you in the next video.